So one of the most basic tools for skill gap management and in general for skill management in any factory is a skill matrix. So in this module, we'll do a little bit of a deep dive on this particular matter, and we'll look into two aspects with regard to using a skill matrix for skill gap management. First, we will develop an understanding of the skill matrix for the purposes of skill availability, record keeping, and the various ways in which it can be used. And the second, then what we'll do is we'll look into design of a simple skill matrix and the various components that are part of that. So let's start with our understanding of the skill matrix as a record keeping tool. So first let's get our definitions right. So what is a skill matrix? So a skill matrix or a skill inventory, when we talk about, it is essentially a record of past performances of operators on various operations. So it is a framework that is used to map the employees' skill levels with the various skills that they perform in the operations. So it is normally called a skill matrix, but there are some other prevalent names also depending on the factory. It is also called skill inventory, and it is also called competency matrix. Generally, there are some minor differences between the two in terms of the level of details or the amount of details that are captured, but in the essence, they all are the same thing. What exactly they do is that it is basically a grid of some form where you have employees on one side and you have the different operations on another side. So typically, let's say employees are on the rows, and you have the columns which are of different kind of operations that those employees perform. And against each of them, in each of the cell, you have some form of a competency, some form of proficiency of the employees against that particular operation. Many times it is kept in form of efficiency percentages, but it is also possible to keep in some other format which are more, let's say, uniform or which are more contextual. For any practical purposes, so this is not a static document. So for any practical purposes, it is very important that a skill matrix is always updated with the latest data. There are attrition, there is absenteeism that happens, there is a performance improvement that happens. The workers go through various kind of trainings, they move between different kind of operations. So it is very important that the matrix is always updated. Then only it is useful. Otherwise, it becomes a historical kind of a document. So skill metrics are very helpful to improve the management efficiency, and when they are used correctly, they help improve the bottom line of factories. So they are essential tools for any company that is driven by data in particular. And within the companies, in particular, they are of maximum usage for the HR department and the production management team leaders. These are ideal for keeping track of skills and competencies through the whole organization. So that sort of gives a bird's eye view as well as a detailed granular level view whenever required, depending on how it is set up and what level of granularity and the recency of data that is maintained there. For production managers, it is a very important and useful tool because it helps them organize their production lines and their teams and operators much more easily. And also, as they start making plans for the future line setups, it helps them to identify any skill sets that are needed based on the project requirements. For HR department, it is also very helpful tool because if they need to hire extra staff, they know what skills to advertise for. And at the same time, they can use the skill matrix and the deployment of the various skills and the deployment plan in general, deployment in various lines, etc. They can use it to schedule the vacation periods or any kind of planned absenteeism that they would want to promote for the employees, while at the same time making sure that there are always enough number of people with needed skills which are available on the site. In operations planning, it comes across as a very useful and handy tool for optimal line balancing. So the IE department or the production managers, they can use it to select the operators as per the requirements of the operations bulletin for each of the style. For example, if as per the plan a particular operation requires, let's say, 60% of pitch time, then they can identify a pool of operators with efficiency level which is around 60% on for that particular operation. This is required because if otherwise you choose, let's say, a more efficient operator, then this will result in higher idle time of that operator, and you basically get lower efficiency than what that operator otherwise would be capable of, and generally they will also be slightly higher cost. So your cost will be a bit of a challenge. And in case you get a lower efficiency operator than the required pitch time, in that case that operator will start becoming a bit of a bottleneck, and you will have more WIP in the system. It can also be used in the reverse manner. So because in the end there will be certain amount of planning that will happen based on the availability of the skills. So by checking the efficiency of available operators and the operation bulletin while trying to balance the line, the IE department can plan more efficient production by clubbing some of the operations and quickly deciding on which operations actually should be done by the same operator and how exactly to distribute otherwise. However, the factories generally report certain challenges, and there are some common challenges while trying to maintain a skill matrix that is always available for use, which is updated at all points of time, which is comprehensive enough, and at the same time handy enough. So one of the most common challenges that are reported is that there is generally a wide variation in efficiency on different dates and styles for operators, and that makes it very difficult or bit difficult to identify one number that should be entered or maintained, because in the end most of the matrix will have a single number against a particular operator and a corresponding operation for which that efficiency or any kind of competency or proficiency figure is being entered. Now there could be multiple reasons, and that's what sometimes the operators may contend, that there could be multiple reasons which could result in lower efficiency of a particular operator, which are not necessarily totally dependent on that operator. That could be external factors such as lost time or line setting time or no feeding and etc. And these all need to be identified and adjusted for before a particular number is kept in. Otherwise it will not be very useful parameter while you're trying to do the planning for future operations. And due to various reasons, operators may also work on multiple operations during the same day, and that typically happens in some of the factories where because to manage absenteeism and all, they may in fact do some kind of a shuffling of operators between different lines during the same day. Now this sort of a thing brings some challenges in averaging and aggregation and monitoring and measuring of the data of these particular operators. So keeping records updated on regular basis with these kind of challenges becomes a time consuming task, and this is one of the primary reasons why many factories do not maintain these kind of registers. However, these are not insurmountable challenges, and in particular the good news is that with the advent of Industry 4.0, there is increasing availability of modern tools such as sensors that can monitor machine utilization data automatically, and they can capture the needle time efficiency of operators. And these devices can capture and automatically update data, so they will always also keep it current, which is one of the most important criteria for a matrix to be usable. But beyond data capture, it is possible for various kind of automation tools and semi-automation tools to go further. They can automatically perform analysis of various kind of variances of efficiency, and they can filter the abnormal data, etc. And they can provide ranges instead of a single number, depending on various conditions. And these systems can then go further by linking them with, say, your attendance system, so they can automatically perform a search operation in case of an absenteeism or in case of an attrition, and they can make suggestions to the production managers and HR departments. So now let's look at a design of a simple skill matrix, and let's just quickly work through on what are the various steps we can follow to make a skill matrix in our factory. So as we mentioned earlier, a simplest skill matrix is basically a table or a grid with employees' names and their skills or competencies, as well as the evaluation against each of those. So evaluation of each employee against each skill or competency of that particular required in that particular factory. Now, for a simple matrix, for example, we can follow the following three steps, which will help us create a skill matrix and a grading system. First of all, we'll have to create a list of skills that are required for operations in the factory. Then the second step is to define how to grade these particular skills for a proficiency level. So first we define what are the skills required. Then we define a mechanism by which we will be grading each skills against a proficiency level. So for example, an efficiency level chart that can be created, which can be mapped with complexity category of each operation, and that could determine the grade of competence. Once we have this, finally we need to have some kind of a scoring system to rank the competence or skill level of operators as per all the different operations for which they have some level of skills and they are proficient in. So let's look at these in a little bit more detail. So first, let's see how can we create a list and create a mechanism to grade each of the operations. So how to create an operations list and grading of the operations. Now, what are operations? Operations are essentially the different steps that are performed to make a garment, right? And these have to be graded on basis of various criteria. So the example criteria could be the critical and non-critical operations, or the skill level that is required to perform a particular operation. So we, production managers intuitively know that which are more difficult operations, which are relatively easier operations. That could also be categorized further based on the machines that have to be used. For example, if it's a single needle lock stitch machine, or an overedge or semi-automatic machine or flat lock machine, etc. And what is the area of operation in that particular garment. So similarly, some other criteria can be created, but these are some of the important criteria, most commonly applied criteria. And based on this, a list, sort of a difficulty level of each of the operation could be decided. Then all the operations that are performed in the factory, a list is created, and then they can be divided across, let's say, three different categories. So it could be grade A operations, which are the most complex or most critical. A grade B operation could be the medium complexity and the semi-critical ones, and grade C operations could be the low criticality and low complexity of operations. And all these operations can then be categorized between these three. So that's sort of one way of organizing it. Another way of organizing it could be that the categorization is done by each machine type, and based on the complexity of operation, there can be a minimum proficiency level that can be defined for each of the operation as per the machine type. So in the example that we have shown, for example, there are the machine types of single needle or double needle and overlock and flat seam, etc. For each of them, the operations can be defined as that. For SNLS, the critical operations are these, the semi-critical operations are these, and the basic operations are these. And they can be called as A grade, B grade, and C grade. And for each of them, there could be a minimum proficiency level that can be defined to say that, okay, if you cross this proficiency level, then you could be considered as skilled in this particular operation. Once we have done that, then the next step is to find a mechanism, or to define a mechanism to grade the operators against those operations. So what we did earlier was that we developed a mechanism to grade each of the operations. Now each operator will be proficient in multiple such operations. So we need to have a scoring mechanism or some kind of a grading mechanism whereby we can grade operators against the skill levels of all different operations that they perform. And to do that, one of the ways is to have a grading table of how many operations an operator can perform from the above tables and what is their efficiency level at work. So that would sort of become the input. As an example, in the table that we have shown, the required criteria have been mentioned against each grade. So let's say for various A grade operations and B grade operations and C grade operations, if a particular operator has more than 5 A grade operations, more than 5, let's say, B grade operations, and more than 10 C grade operations, then that operator can be categorized as A grade. This is just by way of example. These numbers could be very different for your factory depending on how you want to do your grading systems and how you want to put your incentive structures accordingly. But in this particular example, so similarly, let's say for a B grade operator, we can have that there should be minimum one A grade operation that should be known to this operator, and there should be at least 5 B grade operations and at least 10 C grade operations that the operator should have proficiency in. For the C grade operator, we can say that it should be minimum 10 C grade operations, but at least one B grade operation. The reason to do that is because that sort of automatically puts someone into a beginning of the next stage of progress cycle, and hence it is good for motivation. And anyone who at least knows one C grade operation is someone who can be put in the production under supervision, etc. They can be considered as a trainee level. And the final step after having done all the above is that there should be a formal mechanism to evaluate the skills. So what that would require is it would require some kind of a record keeping mechanism of how many operations from the above table that a operator has performed, and what was the different skill levels, efficiency level, proficiency level for each of those operations. And then there has to be a mechanism to match that performance level with the grading table that we have created, and the grade marks have to be created for these operators, and that sort of essentially becomes the grading of each of the operators.